Okay, we've already had a lesson on the quadratic formula. The textbook lesson kind of takes this concept plus it reviews with a previous concept and adds something smaller. So I think it's worth our time to take a look at this. The first example is already absolutely completed for us. They did the entire thing. I really like that they show that first they simplified the discriminant, then they simplified the radical, and then they simplified the whole term. So those are the steps that we want to be completing as we do this. Let's just do one example together to remind us of how to solve using the quadratic formula. I want you to make sure that it's in standard form. So we have quantity squared, quantity to the x, constant number equals 0. That's going to be what gets us into standard form. And then we can identify A, B, and C. And this is remembering that in standard form, we have ax squared plus bx plus c. So we're looking for the numbers that belong in those places, and we'll use those in our formula. So a, even though nothing's written here, a is 1. If it were 0, this term would be gone, and it wouldn't be quadratic at all. We couldn't solve it. So when nothing is written in front of a variable, it's a 1. It's really a 1 there. Okay, b, in this case, is -9, and c is 27. Okay, so now we're just going to plug this into the quadratic formula. I think I have room here to do it. Let's do this. X equals -b. Everywhere I'm saying a letter, I'm going to put parentheses and the number that belongs in there in that place. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now we recommend take your calculator, do some mental math if you want to, but then also calculate just these numbers under the radical symbol. Don't put the radical symbol in your calculator. We just want to find out what numbers we're getting there. 1, 2, 7. I got -27 here. So what we're going to do is say x equals something plus or minus square root of -27. Okay, let's simplify these other pieces while we're at it, since we've got to rewrite. -9, that's going to be 9. And then on our denominator, 2 times 1, that's just 2. Okay, now we want to simplify this radical expression. So the square root of -27. 27 is divisible by 3, and then divisible by 3 again. So I've got a pair of 3's in there and 1 3 left over. So I'm going to say x equals 9 plus or minus. I'm taking a 3 out of the radical. And because it was negative right here, I'm going to put an I as well. And then the square root of the thing that got left behind was the 3 there, all divided by 2. Okay, we want to check 3 things to see if we can divide them away. Is this number and this number and this number, are they all divisible by some common factor? And the answer is 1. The greatest common factor here might be 1. So if I can't do any further simplifying, that's the end. Just going to circle my answer and we've got it. Okay, this was review. We did a lot of study on this on 8-1, so if you need to look back at that video, feel free to do that. Okay, I put example 5 on this page just because it fits perfectly, but turn the page, please, over on the other side. There's example 3. Okay, now we're going to be talking about how to determine the number and type of roots for a quadratic equation. And another word for roots are the zeros or solutions. So how can you determine the number and type of solutions for a quadratic equation? Well, they show how to do it graphing. That's good. It takes a little bit of time. They're showing this one has 2 real roots. This one has 1. This has 0 real roots because it doesn't cross the x-axis at all. Oh, that's another name for them, x-intercepts. That should be an S, but I can't quite make it work. Too small over there. Okay, one way that we've done before, so hopefully this is reminding you of something, is we found the discriminant. If the discriminant is positive, then you get 2 real roots. If the discriminant is 0, then you get 1 real root. And if the discriminant is negative, then you get two complex roots. We use the word imaginary roots. Complex is actually more mathematically correct, but I'll take either answer since I started teaching you imaginary roots. Okay. They're saying roots. We could say solutions here. That's what I typically say. So we've done this, right? We found the discriminant. We had a whole lesson on discriminant, 8.0. And we can find the discriminant, and then we can say how many and what type of solution. So let's take a look and try one of these problems, right? Let's do this one. It's already in standard form, so I can identify A as 16, B is 8, and C is 1. Now, since it didn't say solve, it just says describe the nature of the solutions, I'm just going to use the discriminant. I'm not going to use the entire quadratic formula, just the part that says b squared minus 4ac, and that's going to lead us to how many and what type of root. So I'm going to replace each letter with the number that we know goes in its spot. So this, I think it's going to end up being 0. 8 squared minus 4 times 16 times 1 gets us 0. Okay, if our discriminant is 0, then we get one real solution. Let's think that through for just a second. Suppose that we had, let's see, we can use the actual numbers from here. X equals negative b plus or minus the square root of, we found out that's 0, all over 2 times a, that's going to be 32, 2 times 16. Let's simplify on the numerator, right? The square root of 0 is 0. So now I'm looking at negative 8 plus or minus 0. Let's take a look at each situation. Negative 8 plus 0 is negative 8. Negative 8 minus 0 is negative 8. So we got the same thing either way. Did this plus or minus 0 affect our answer at all? No. If I add 0 or if I subtract 0, nothing changes. So because of that, my numerator is just going to be negative 8, my denominator 32. So my one solution would have ended up being negative 1/4. So we can see that when the discriminant is 0, that plus or minus 0 doesn't change anything. That's why we get one solution out of those. Okay, that also should have been review. If you feel like you need more of that, look back at the 8.0 video. Okay, now, this last thing I just find really interesting. There's only 3 homework problems about this. It's not the most critical concept, but I really like it. So I'm going to have us try this. This says, what values of b will cause this function to have one real solution? What values of b will cause this to have one real solution? Okay. If a quadratic equation has one real solution, what do we know about its discriminant? To have one real solution, its discriminant has to be 0, right? 0 is the only way we get one real solution. So they want us to find a number for b that's going to give us one real solution. Okay, let's try the discriminant, right? If we can make the discriminant equal 0, then we've got it. So they've identified that a is 2. In this problem, b is literally b, okay, and c is 18. The discriminant is b squared minus 4ac. So we've got b squared minus 4 times a times c, and we want this to equal 0. If it equals 0, then we know that it satisfies the situation they were talking about, that this entire equation will have one real solution. If I take negative 4 times 2 times 18, I will get negative 144. So we've got now the equation b squared minus 144. In this case, when I plugged it into the calculator, I did do a negative there instead of minus. So typically when you're doing b squared minus something, we have a number here. Because we didn't have a number on this part, then putting it in with negative will be the best option here. Okay, we want to isolate b squared, so let's add 144 to both sides. So we have b squared equals 144. And now we have quantity squared equals number. We can take the square root at this point. We'll have b equals plus or minus, what is the square root of 144? 12. So in this equation back here, if we plugged in positive 12 for b or negative 12 for B, it would be an equation that has one real solution. And they solved the exact same thing and found that same answer, positive 12, negative 12. Let's try out the try it problem. This says determine the value or values of B that ensure that this has two non-real solutions. If they have non-real solutions, what do we know about its discriminant? It would have to be negative, right? Discriminant would have to be negative to get two non-real solutions. Okay, so let's try out and see if we can get a discriminant that's negative. Okay, so we have A is 5, C is 5, B is literally B again. So we've got B squared minus 4 times A times C, and we want this to be negative, so I'm going to say it needs to be smaller than 0, less than 0. Negative 4 times 5 is 100, so we've got B squared minus 100 needs to be less than 0. I'm going to add 100 to both sides. That will give B squared is less than 100. I'm going to take the square root of both sides, and we will get B needs to be less than 10, and an inequality rule that you don't really have to worry about. It doesn't affect the other problems, but if you have a negative, then you got to switch things around. B would also need to be greater than negative 10. Okay, this, if we've got this, I'm satisfied with that answer. Like I say in the homework problems, neither of them really go in that direction. I'd like to try one of the homework problems with you before I turn off the video. So the one I would like to try, well, let's just glance at what we have. First, it says describe the number and type of solutions. Using the discriminant is going to help you out with this one, right? Next, number 2 says use the quadratic formula to solve. So we want the whole formula, x equals negative b plus or minus the square root of the whole thing, okay? Number 3, at time t seconds, the height h of a ball thrown vertically upward is modeled by this equation. About how long will it take for the ball to hit the ground? So I'm going to draw a little picture. We want to pretend that that's vertical and horizontal. Okay. This line represents time t. This line represents height h. The person starts here, and they're going to throw the ball, and it's going to go up and down like that. It's opening downward because the A is negative, right? I want to find out how long it takes for the ball to hit the ground. So I want a solution to this equation. Now, in the world of theoretical mathematics, I have two answers here, right? One happened there before the throw started, so that would be traveling backward in time. That wouldn't make sense to our story. So the negative answer that I get, I'm going to ignore that one and just focus on the positive answer. Okay, let's go ahead and try this one. I think I'm going to use quadratic formula to solve it. So A is negative 5, B is 33, C is 4. So we're going to say x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, start by simplifying the discriminant. So 33 squared minus 4 times negative 5 times 4. I got 1169. X equals negative 33 plus or minus the square root of 1169 all over negative 10. Okay, for a story problem, they generally want a decimal approximation rather than a simplified radical answer. Okay, so we're going to try to approximate a rational answer. We'll give a decimal approximation. So in one case, we're looking at negative 33 plus the square root of 1169 all over negative 10. And the other situation, we're looking at negative 33 minus the square root of 1169 all over negative 10. I'm going to take a second and calculate this one. I'd like you to calculate it in as well and see if you get the same decimal approximation that I do. And this one I got negative 0.1190641995. I'm just going to stop there at 3 decimals. This one is the backwards in time answer, isn't it? Negative 0.119 seconds for the ball to hit the ground. Doesn't make sense in the story, so I'm going to ignore that one. Hopefully this one ends up being positive. Let's try it. Negative 33 minus the square root of 1169. Then I hit enter, divided by negative 10. Whoops, and I made a mistake. Sorry, let me type the whole thing again. Divided by negative 10. In this case, I got 6.719064199. So I'm going to stop there. It's going to hit the ground. The ball will hit the ground at approximately 6.719 seconds. So if we had that picture happening again, this happens at time 6.719 stuff approximately. That one was at negative 0.119, but didn't make sense for the story, so we're discarding that answer and just going with this one. All right, try out the other problems. We have a few where you're finding errors, using quadratic equation, using the discriminant, and then these last three go with that example 5 that we described before. So we're using our discriminant to try and get one real solution or two real solutions. Good luck, happy working.